Okay, there are steps we can follow when we are solving these direct variation problems, and these steps I think will help you to go through and figure out each example and go through these steps to figure out and solve for those examples or for the problems you're working. So the 4 parts from example 1, so that was the example with the Rubik's Cube is one of them, illustrate a procedure you can use to solve variation problems. So step 1, you're going to write a general equation that describes a variation. We did that with the Rubik's Cube problem when we said that S, or the surface area, equals K times E squared, E being that edge. For step 2, for any variation problems, you're going to substitute the given values into the general equation and solve for K. For that Rubik's Cube example, that's when we plugged in 150 for the surface area and 5 for the edge length, and we solved for K. Step 3 for these types of problems, you're going to use the K value to write the variation function. And then finally, step 4, you're going to evaluate the function at the specified point to find the missing value. Okay, so let's go through some examples, and we'll go through these steps as we go through these examples so you can see how these steps work for each of these types of problems. So example 2a, suppose b varies directly as the 6th power of g. If b equals 729 when g equals 2, find b when g equals 10. So step 1. And I'm just going to use these steps. First step is write a general equation that describes a variation. So we know our direct variation is y equals kx to the nth. So it's going to be something like that. They're telling us for this example, b varies directly as the 6th power of g. So we can say b equals k times g to the 6th power. That's what they want for that one. That's step 1. Step 2. Substitute the given values into the general equation and solve for k. So the given values, they're saying if b equals 729 when g equals 2. Let's start with that. So b is 729 and g is 2. Okay, let's solve for k. 2 to the 6th power, because we have to do that first, is 64. Divide both sides by 64, and you have k equals 11.4. That's all step 2. Okay, step 3. Use the k value to write the variation function. I'm just reading up here. Okay, now we have our k value. Let's use it to write the variation function. And we're just going to put it back into this function we wrote already in step 1. So we can say b equals, we know what k is, it's 11.4 g to the 6th. It's just that same function from step 1. We just plugged in 11.4 for k. And finally, step 4, evaluate the function at the specified point to find the missing value. So they want us to find b when g equals 10. So we're going to find b, and we're going to use this formula right up here. So b equals 11.4, and they say g is 10, and we know it's g to the 6th. So we need to figure out 10 to the 6th power. That's actually quite a bit. And then multiply by 11.4, and you should get about 1.14 times 10 to the 7th, or 11 million in other words. It's a big number. And that's when g equals 10. Okay, let's work through another example using those 4 steps. So you need to learn and memorize and understand those 4 steps, because it's going to always be the same for the direct variation. So example 2b. Suppose m varies directly as the 5th power of p. If m equals 96 when p equals 2, find m when p equals 5. So step 1, that was write a general equation that describes a variation. We're going to use our direct variation function, and we can say y equals k times x to the n. So for this one, we have m varies directly as the 5th power of p. So m equals k times p to the 5th power. There is our general equation. Step 2. That is substitute the given values into that general equation and solve for k. So here's our general equation we just wrote. Now we're going to substitute in if m equals 96 when p equals 2. Okay, so m is 96 when p is 2. So I'm just plugging in 96 for m and 2 for p. And I'm going to solve. 2 to the 5th power is 32. We got to do those exponents first. Now I'm going to divide both sides by 32. And I have k equals 3. 96 divided by 32 is 3. Okay, step 3. That is use the k value to write the variation function. So I'm going to just use that general equation that I wrote first. And I'm just going to rewrite it again. M equals k times p to the 5th. But this time I'm going to plug in that k value I got down there in step 2. So m equals 3p to the 5th. That's the using the k value to write the variation function. Finally, step 4. Evaluate the function at the specified point to find the missing value. So m equals 3p to the 5th, and they want to know find m when p equals 5. We're going to solve for m when p equals 5. So m equals 3 times 5 to the 5th is 3,125 times 3 equals 9,375. So m equals 9,375 when p equals 5.